better. All right, today is 11-1. All right, so the big thing that we've talked about previously is expressions. That's what we did before break. We were dealing with equivalent expressions, how we expand expressions, how we factor expressions. But we didn't really get to equations that much. Now, what is the major difference between an expression and an equation? Shahib, I think you about left out of your seat.
If I were to, like, an equation has an equal sign, if you think about it, like it has an answer.
An equation has an equal sign and it has an answer. I agree with both of those.
And an expression just has a problem.
I don't know what you mean by problem. Problem's kind of a vague word. An expression is, there's a much better word that I'm thinking of. You know? But then that's inferring that there is an answer.
Yeah, because isn't like 9
Why do we use expressions?
Unknown.
Why do we use expressions? Why do we use variables? Are we missing Jackson too, or did he go to the bathroom? Who's binder? Is that his binder?
Yeah, he's here.
Why do we use expressions?
We use expressions to find because we don't know the answer yet. So we use
Nah, again, you're talking about answers. If I say 3x plus 1, what do you think I'm representing with that? Why would I write something like that? Trying to get you guys to think more conceptually as we go deeper into this math. We use expressions. Shahib, we'll give it one more shot. Zach?
When there is an unknown answer, because like that is an expression. An expression because you don't know what x is.
So, we use expressions to represent a situation where something is unknown. We use an equation to represent a situation where something is unknown but can be solved. This cannot be solved. I cannot determine what x is. X is just a variable. It has some value that we are unaware of and we cannot figure it out. If I now do that, what's x? 2. Because that's the only value that can go in here and make this true. So the big thing as we start to work with equations is we have to keep them true. We have to keep them agreeing with each other. And we do that through our properties of equality. So here we have our bagel baker. Our bagel baker.
I don't want a dozen. I only wish to pay for one bagel.
I just have one price. Don't you have 11 friends you could share with?
So, if this bagel baker, like any smart man, wants to make that woman happy and just sell her one bagel, fine lady, stop complaining, here's one bagel, he would have to determine the price to charge her. He's never sold a single bagel before. How would he do that? We know his price for the dozen. Oh, you guys...
Nate's usually the one who runs up there, so.
Nate, we miss you. Nobody passed out notes. Olivia, what do you think?
You just have to divide 780 by 12
Ah, now why?
because a dozen is 12.
So we want to start by writing the equation to represent this situation. We can write an equation by setting up two equivalent expressions. So we are going to do this by knowing the two things that Olivia just said. She whizzed through it real fast. So Olivia said, we know the price is what? The price is $7.80. And that's the price for what? For 12 bagels. So we can set up an equation that is just 12 bagels equals 780 or 780 equals 12 bagels, but we don't know what the individual price of a bagel is. So that's when, like Olivia said, we just divide by 12. Now I know some of you will quickly identify that this slash right here kind of told us what to do because it's the price per bagels. and we can use that to solve the unit price. But we want you to have this equation written where you show that on both sides I'm doing the same thing, and therefore it stays balanced, it stays true. The price of one bagel, if he wanted to charge it to that crazy lady, would be, anyone got it yet? Yeah?
65 cents.
Yep, 65 cents. My smart board is being a pain in the butt.
So the person, if we were to like watch the video over, they've seen that.
Huh?
Like when you orient it, would like they'd be able to see that?
I'm not certain because I don't know if that only. All that it matters is does it show on this screen. If it shows on this screen, which I think it does, like because that projector shows exactly what's on there. So our properties of equality, we start easy with addition and subtraction. I'm gonna just whiz through this really fast.
You
I'm
can
gonna
think
show
of
you
solving an
example
equation as transforming the equation into a simpler equivalent
I'm going to
equation.
need two
Your goal
volunteers, by
equals
the way.
b plus c for all
Here we're just
numbers
showing
a,
that if
b,
I
c.
add something to both sides, I know that 6 is equal to 3 times 2. I know that this is a fact. It is true. So it's an equation. If I add 5 to both sides, it stays the same because I did the same thing to both sides. That's like saying if you and your sister were the same height and you each grew 3 inches, would you still be the same height? Yes, because the same change happened to both of you. Come on, smart board. All right, 2 volunteers. Anybody? James and let's go James and Seth for this one, just because you guys are kind of the same height. We're trying to make a balance, so that's why I'm just going to pick 2 people that are relatively the same size. There we go.
Nate would have been easier if he lived here.
I'm sorry, you will survive without Nate, I promise. You can make it through the day. All right, coming up. James, I have these gifts for you.
Yay!
What? That's a gift?
And Seth, I have these gifts for you. 2, 4, 6, 7, 8, 9, 10, 11, I believe. 2, 4, 6, 8, 10, 11. Here we go. All right, gentlemen, let's show the class your wonderful gifts. Now, James and Seth are now a balance. If you guys know what a balance is, you've seen it in science where that's how they used to measure gold and things like that. So if I take something away from James, what happens to James's side of the balance? No, if I took weight away from you, your side would go up and your side would go down. Or yeah, okay, so you guys see what I'm trying to do here. All right, so now we're balanced again, perfectly balanced. So show everyone what you got. Try to not drop it on the floor, but so Seth has 11 1 blocks. James only got 3 1 blocks, but he's also got this variable x. We want to know what's the value of that variable that James is holding on to. So, Ella, you've had your hand up. What would you do?
So since Seth has 11 and he has 3 1s, the ones that he has 8 more, so 3 plus 8 is 11.
I like your reasoning. I really like your reasoning.
I don't really know how to explain it, just it's like.
Do they have any shared objects, or do they have all the same objects, or do they have totally different objects? Sorry, Sheed?
I was gonna say that James has 8 because like if 8 plus 3 equals.
I know. I get that you guys know the solution. I'm trying to visually represent it to help put it in your memory for good. Karen? Yeah, they both have 1 blocks, right? And right now they're even. If I take a 1 block away from James, James's side now goes higher, and Seth's side now goes lower because Seth has more. So if I take 1 away from Seth, now they're even again. If I take 1 away from James, they're not even. Go down. And then if I take 1 away from Seth, now they are even. I took 2 away from Seth, so now you're lower and you're higher. And to balance this out completely, I need to take another away from James. I now took 3 away from James and 3 away from Seth. which now leaves James only holding the value of x. So if they're still equal, what's the value of x equal? 8, which you guys already figured out because you know the addition, but that's conceptually what we're doing. Every time we do something to one side, you're out of balance, so you have to do it to the other side to get back in balance. Thank you very much, sir. Thank you. So, on here, I meant for this to already play. I want you guys to show.
Likewise, on tiles to each pan balance tool to model and solve equations, you can add x and.
Here we go. I want you guys to show on your balance. We're going to cross out 3 of these and do it on both sides. However, you artistically show that we're going to get rid of 3 of those. You can show like a hand taking them away or something if you want. Over here, mathematically, my best advice is always write your variable first. So I would rewrite this as x plus 3 equals 11. I would then show that the math I did on both sides was minus 3. Thank you, Zach. And we know that 11 minus 3 gave us the x value of 8. Try the got it on your own. Sorry, it doesn't say got it. I don't know where it disappeared to on my notes, but it's just the next thing on the notes. Sure, you can write got it beside it if you want.
Oh my god.
I was waiting for that to happen.
They're like bubbles sitting on the ground.
I know, bubbles are fun.
This scared me though.
It's the variable bubbles.
Oh.
What, the x variable is a thing of...
my desk.
I'm sorry, change desks.
No.
It's just soap, it just makes things clean. Alright, so what did we do, Ashton, in order to isolate the b value here? Now be careful. If I back up, the first question you should be asking yourself is, what is happening to my variable? So Ashton, if I ask you what is happening to b, what's being done to it?
You're taking 2 from the variable.
Yeah, we're taking 2 away from b. So to undo that happening, to do the inverse operation, what do we have to do? We have to add 2. Because we see subtraction, we have to add 2 to both sides. And that gives me that b is equal to -8. Be careful when we have positives and negatives. Some of us are still struggling with that. I need yo necesito, by the way, in case we want to incorporate some more Espanol. I need 2 more different volunteers. Jackson and Leah.
Dang it. Am I too short?
No, just first 2 people already. Jackson has some X's. Sorry I didn't label both of them as X's. And Leah, let's...
Bubbles are best.
I don't know how hard we want to make this. Hold on, guys. 1, 2, 3, 4, 5, 6, 7. No, wait. 2, 4, 6, 8, 10, 12. Okay. All right. Can you guys set up your balance? So stand beside each other. Be equal. So then if I take something away from you, no, you go up because it's less weight, right? Yeah. Okay. Perfect. And I give it back to you. Just balance back out, right? Okay. So now this gets complicated. Think. We have Jackson holding 2 X's. Leah holding, how many 1 blocks did I give you? 12? Leah's holding 12 1 blocks. How can I figure out the value of the X? What do I do? Don't just tell it to me. What do I do? Lily?
So I would take an X away and
All right, hold on. So give me an x. Leah, give me an x. Give me an x. She's
Like 6 because it's half.
no, but you said take an x away.
No, I said take half of it.
No, you said first take an x away.
From him.
But if I take an x away from him, I have to do the same thing to Leah. So you don't actually mean take an x away.
No.
What do you actually mean?
Divide each one by 2.
What she actually means is slice it in half. Because I can divide non-like terms. I cannot add or subtract. What I wanted, and thank you for that. I should have set this up before class. I was hoping somebody would tell me to take something away because you cannot do that. You have 2 of some unknown value equal to 12 known values. If I remove a known value, like subtract it, I'd have to subtract x from the other side, which is impossible. If I divide by 2, can you give me half of yours, please? Boom. How many do you have left, Leah? How many do you have left, Jackson? So we found out, well, 1 what? X. So we found out now that x equals 6. So be very careful, thank you participants, when you see that there's multiplication or division happening, do not fall into the trap of trying to subtract things away. A lot of times, if we have non-like terms equal to each other, the only thing we can do is multiply or divide. So somewhere on your paper, I can probably find a space for you. Probably at the top of the back here, up here where it says name or something, go ahead and write that situation that we just showed. 2x equals 12, and we had to actually divide by 2 to find that x equals 12. That is exactly what the property of equality is telling me. Sorry, that x equals 6. Is that whatever I'm doing, I have to be able to do it to both sides. If I can't do it to both sides, I cannot do it. So with d divided by -5, I start again by asking myself, what is being done to my variable? So Ella, what's being done to my variable d? Yeah, it's being divided by -5. So when we think about undoing that, how could I undo a division by -5? We multiply. What do we multiply by? What do we say? Who thinks that we multiply by 5? Who thinks that we multiply by -5? Whatever number is being used, that's...
Let's play. One of these things is not like...
Not oriented exactly right. It skipped over that section. So because we have division by -5, we multiply by -5. And you can put -5 over 1 if that helps you. It helps me because then I see that they're both in fraction form. I do the same thing on the right side. You should be writing the work to show that we're doing the same thing on both sides. These -5s cancel each other out, and I'm left on the left side with just 1d. Again, we don't need the 1, but we can put it. 7.2 times -5. Sheeb? -36. What is being done to the p? Seth? What is happening with it? Add, subtract, multiply, or divide? It's being multiplied by... So we identify there is multiplication by -2. So we want to, Karen, divide by -2. So we show on both sides we divide by -2, divide by -2. Guys, some people, especially because this is so small up here, some people find it nice to go ahead and draw like a line, whether it's dotted or solid, to show I've got a left side and a right side. If I divide on the left side, I divide on the right side. I always have to have identical things happening, unless there's an equal sign, because the next step, there will be an equal sign. P equals, well, 1 divided by -2 is just -1/2. And you could write that in fraction or decimal form. negative 1/2. Questions? Try Z got it on your own. Mr. Boyer, what do you see being done here? What's happening to the variable?
It's being divided.
It's being divided by?
0.5.
Exactly. So Peyton, that means that we want to by, we multiply by 0.5 on both sides. I can show it as a fraction if I want to. That then gives me that my m value must equal, Zach? 5.5. Questions, comments, concerns to this point? All right, ready for game show?
Yeah.
All right. Question?
Yeah, couldn't you just put the 11 on top of the fraction?
Set up a proportion?
Yeah.
Yeah. So, I was waiting to see if anyone would ask about that. This is essentially the same thing as when we set up proportions. So we have m over 0.5 equal to 11 over 1. And then I can cross multiply. M times 1 will be equal to 11 times 0.5, which is essentially what we just did. That's another way to solve equations. Except that we use more when we're solving proportions, but a proportion is an equation. It's just a fraction equal to a fraction. Good question. All right, we're going into another exciting round of one of these things is not like the other. You will see that 3 of these things.
Let's play. One of these things is not like the others. For each screen, 3 statements have the same solution. Cross out the one statement that has a different solution. Let's see what's behind the first curtain.
Game show hosts always have weird names.
We'll just call him
Wayne
Chick-fil-A.
Brady.
I know.
How do you do it?
And language arts.
That's not going to help. It's the pressure. All you need is release the pressure.
Okay. I'm so thirsty though.
You know that hot liquids create pressure and like outward, and cold objects when put into something create inward
You're
pressure?
distracting me. Distracting or
The water bottle was distracting us.
Sorry.
Can we use a calculator?
Yeah, but you shouldn't really need to. I was having that discussion with some of my friends over break, the fact that yes, you will always have a calculator because of your cell phone, but that doesn't mean that you should always use a calculator.
Yeah.
What?
Are we just doing round one of both?
You can do both rounds. If you get done with round 1, move on to round 2. I will start taking round 1 answers then.
Oh, I got
Noah, do you want to pick one of these to tell me what to do?
I guess for the first one
Okay.
would divide 60 by 12, right? to find
Yep. Well, really, we divide on both sides, but I agree. The math that we care about is the 60 divided by the 12, which gives me n equal to 5. Pranav, can you pick another one to tell me how to solve?
Can I do the third one?
Sure.
So we have n divided by 1.25.
Uh-huh.
And we have that equal to 4. So basically we can do multiplication because that's the inverse operation of
Yep.
division. So then the 1.25 and the other 1.25 will cancel out. And the 4 times 1.25 is 4.
Yeah, so when we multiply on both sides, we again find n is equal to 5. Lily, will you pick one to solve?
Okay. The last one is wrong.
Why is that? How'd you get there?
The different solution because I just did 10 minus 15.
Yeah, because we see that there's addition of 15 happening on both sides, we subtract by 15 and do it on both sides, which gives me n is equal to -5. So, again, as it asked, you want to cross out the different solution. Oh, my green is goofed up today. Come on, green. And, right, what do I do on the second one?
It's, you just add 3 3/4 to,
Yep. Which I'm just going to write as a decimal just to make my life easier here. And it does also give us n equal to 5. So the fourth one's the only one that did not match. Try round 2, and if you are getting done with round 2, verify with a neighbor that what you did is correct. Zach, can you pick one of these to tell me what to do?
The first one.
First one, what do you want to do?
So what I did was, so the 3 divided by the 4 is or the fraction on the left side is basically 3 divided by 4. So you would do multiplication on both sides.
So this goes back to the first question you ask yourself. Do you know what it is? Because I've said it a bunch today. You ask what is happening to the variable. So we have to look specifically at what's being done to the variable value.
So you would subtract by 1/2.
Yeah. What we see is there's addition happening to the variable. So I agree. On the left side, Zach saw division happening, but that doesn't matter because that didn't have to do with the variable. The variable just has addition, so we subtract by 1/2. Another way to think of 1/2, but in fourths. 2/4. So 3/4 minus 2/4. We get W equals 1/4. Check with your neighbors. I feel like some of you guys are just kind of waiting for the answers. Verify with your neighbors. If your neighbor doesn't have answers, give them a hard time. Ask them what they've been doing.
What you been doing, bro? I know.
Are you just trying to see how tall you can get your hair?
See, I woke up this morning and
So did most of us.
it was just like it was up. And I was like, I tried to put it down, it just kept going up. And I was like, oh my gosh. Oh my, no.
They hurt. I've never had them, but I've had friends that have them. They hurt apparently.
They do. I have one.
Or no, cornrows is what I'm thinking. Cornrows hurt. I don't know if dreads hurt, but dreads are gross. Because they're like dirty, greasy. All right. Olivia, can you pick another one to tell me what to do?
Okay, the last one.
The last one. What do we do there?
I just did 5 W divided by 5.
Yep.
And then that canceled out. And then I did 1 1/4 divided by 5. And I got
So here, I would just rewrite it as 5/4 divided by 5, which is really, remember, keep, change, flip, times 1/5, because I changed from division of 5 to multiplication of 1/5. The 5's cancel out, and we get that W is 1/4. So that one looks good also. Same as my first one. Grace, can you pick one to walk me through?
the second one.
The second one, what's being done to my variable?
It's multiplying by 14.
It's multiplied by 14, so we,
Multiply 3.5 by 14.
so we
Oh, divide.
divide because we have to do the inverse operation. And that gives me W equal to 1/4. So we're assuming that that third one is going to be my wrong one, my other answer one. Carrie, can you walk me through how we solve that third one? Yeah, we really look at what's happening. There is subtraction of 0.75, so we add 0.75 or 75 hundredths to both sides, but the math we really care about is over here. What'd you get for your answer? Do you have it? So we actually still get 1/4, but it's negative. And because it's negative, it is different. That one does not match. Now in the got it, and then once we get done with this, I will just give you guys time to work on your progressing to masteries. On the got it here, we see a fraction attached to my variable. I'm going to go back over to here so I have a little bit more room. 4/3 times a. Now we'll solve this in a second. The 2.5a equals, or we can solve that first. Ryan, do you want to tell me how to solve 2.5a equals 30?
Do you add 22.2?
Back up. I'm right here.
Oh, okay. Let's see here. You divide 2.5 to 2.5 and 30.
Yeah, we divide 30 by the 2.5. I think you just said it a little weird. And when we divide that by 2.5, we get that a is 12. So now we want to see, does one or two or both of them have the same solution? Ellie, do you know how we would solve one?
You do 16 divided by 4 thirds.
But divided by 4/3.
Yeah.
So, hold up. What you just said, 16 divided by 4/3 is not wrong. But that's not how we want to do it. Because we don't divide by fractions. It is evil, it is messy, it is bad. We don't divide by fractions, Jackson. Instead, we what? Keep, change, flip. So really here, what I want you guys to think about is when you have a fraction in front of a variable, what you do to get rid of that fraction, and you might want to write this down, is multiply by its, Karen, reciprocal. So when we see a situation like a fraction multiplied by my variable, we multiply, which seems counterintuitive because it is multiplication and we are going to multiply. That's the one where we are using inverse operations, but it doesn't feel like we are. Because we see multiplication, we do multiplication, we multiply by the reciprocal. So I do it on both sides. That's helpful to put my 16 over a 1. My left side, 3 on top and bottom, cancel. 4 on top and bottom, cancel. I get left with just a. We're going to do it on the right side to make my life easier. Close. Not cross cancel.
Cross simplify.
Yeah, cross simplify, cross reduce, however you want to call it. 16 and 4 both share a common factor of 4. So we divide by 4 there, and we divide by 4 there. 4 times 3. 12. 1 times 1. 1. So we just get 12. So 1 has the same solution. Woohoo! But now, part 2. Ashton, what do I do in part 2?
Okay. So you say you add 22.25 to the.
I agree. We add it, and really, when you think about doing something in an equation, you don't have to think about where, because you're doing it on both sides. You have to. It's the only way that you can do it, is to do it on both sides. So now, A, when I do that addition, still ends up as 12. So both of these work. All 3 of these have the same solution. Are there any questions? No preguntas? Bueno! Alright, so your progression to mastery is right up here. Notice it says A7, Accelerated 7, Chapter 10, P to M, that means progression to mastery. So I ran out of manila folders. So if you are progressing or not progressing on that, please come grab one of those and go ahead and start working on it. You may use your mastery as a reference. So we went over it together. It's posted in Schoology. You may use your